You may have seen how to take the derivative of constants, powers of x, and polynomials, but how would you take the derivative of something like this? In this video, I'm going to show you how to take the derivative when a given function includes the multiplication or division of two or more differentiable functions. First, let's talk about how to handle derivatives involving the multiplication of functions. To take such derivatives, we'll need something called the product rule. The product rule states that if you want to take the derivative of two functions multiplied together, start by writing the first function and multiplying it by the derivative of the second function. Then, add the second function multiplied by the derivative of the first function. Mathematicians write the product rule in this generalized form. The derivative of f times g is equal to f times g prime plus g times f prime, where f and g are two things being multiplied together, and f prime and g prime are their respective derivatives. Let's try some examples of using the product rule. Take a look at the function p of x equals x to the fourth power times the natural log of x. To find the derivative of this function, remember that the product rule says that the derivative of f times g is f times g prime plus g times f prime. In this case, f is equal to the first function, x to the fourth power, and g is equal to the second function, which is the natural log of x. We need to write down f times g prime. In this case, that will be x to the fourth times 1 over x, since the derivative of the natural log of x is 1 over x. Together, these can be reduced to x cubed. The last step in using the product rule is writing the term g times f prime. Remember, in this problem, g equals the natural log of x, so we'll write that multiplied by the derivative of f. Since the derivative of x to the fourth is 4 times x cubed, we write ln of x times 4 times x cubed. The derivative of the function p of x is equal to x cubed plus the natural log of x times 4 times x cubed. Let's try another example. Use the product rule to find the derivative of q of x equals e to the x times cosine of x. Remember, the product rule says that the derivative will equal the first function times the derivative of the second plus the second function times the derivative of the first. Let's write down the first function, e to the x, multiplied by the derivative of the second function. Since the derivative of cosine of x is negative sine of x, we get f times g prime equals e to the x times negative sine of x. Then, we're going to add the second function multiplied by the derivative of the first function. Since e to the x is its own derivative, g times f prime is cosine of x times e to the x. Combining both parts, we get q prime of x equals e to the x times negative sine of x plus cosine of x times e to the x. We can clean this up a little bit by factoring the e to the x out from both terms and rearranging a bit. E to the x times the quantity of cosine of x minus sine of x. Let's take a look at one more example. Use the product rule to find the derivative of r of x equals 2x times e to the x. Now this is technically three things multiplied together, 2, x, and e to the x. But we can combine 2 and x as f and leave e to the x as g. Using these definitions, the derivative of r of x is equal to the first piece times the derivative of the second, which is 2x times e to the x, plus the second piece times the derivative of the first, which is e to the x times 2. Simplifying, we get 2x times e to the x plus 2 times e to the x. Or we can factor out the 2 times e to the x and get 2 times e to the x times the quantity, x plus 1. Some students have difficulty committing the product rule to memory. However, with a bit of practice on your own, you should become comfortable with using it. While the product rule helps us find derivatives of functions containing multiplication, we have another tool called the quotient rule to help us find derivatives of functions containing division. The quotient rule states, The derivative of a fraction is a new fraction whose numerator equals the original fraction's bottom times its top's derivative minus the top times the bottom's derivative, and whose denominator equals the original fraction's bottom squared. If you didn't catch all that, don't worry. I have a way to help you remember the quotient rule. Let's say we want to take the derivative of this fraction, high over low. By high, I mean to indicate the numerator, and by low, the denominator. To get the derivative of this fraction, the quotient rule can be remembered in this way. Low d high minus high d low over the square of what's below. This little saying is a memory tool to help you remember the quotient rule. Now here's what that means. The derivative of a fraction will be another fraction. The top of this fraction is given by the first part of the rhyme, low d high minus high d low. Write the denominator, low, and multiply by the derivative of the numerator. That's what I mean by d high. Then subtract the numerator, high, multiplied with the derivative of the denominator, d low. The second line of the rhyme says over the square of what's below. This means the denominator of the solution is equal to the starting denominator squared. To use the letters f and g, the quotient rule can be written in this way. The derivative of f over g is the quantity g times f prime minus f times g prime divided by the quantity g squared. Remember, low d high minus high d low over the square of what's below. Let's try this out on an example. Use the quotient rule to find the derivative of the function s of x is 9x divided by the quantity x cubed minus 1. Since this function is in fraction form, we know that its derivative will also be a fraction. The top of this fraction will equal low d high minus high d low. In this case, low equals x cubed minus 1, and d high equals the derivative of 9x, which is 9. So the first thing we have is x cubed minus 1, the quantity, times 9. We're going to subtract high d low, which is 9x times the derivative of the bottom, which is 3 times x squared. So the numerator of the derivative will be equal to x cubed minus 1, the quantity, times 9 minus 9x times the quantity 3 times x squared. Let's multiply and collect like terms to clean this up a little bit. We can distribute our 9 into our parentheses and get 9 times x cubed minus 9 minus 27 times x cubed. Then we can combine our x cubed terms and we'll get negative 18 times x cubed minus 9. Now the bottom of the derivative equals the square of what's below. So that'll be x cubed minus 1, the quantity, squared. The derivative of s of x is then the quantity negative 18 times x cubed minus 9 divided by the square of the quantity x cubed minus 1. Let's try another example with the quotient rule. Find the derivative of t of x equals e to the x divided by sine of x. To find t prime of x, we know we are going to have a fraction. The top will equal low d high minus high d low, so that's sine of x times the derivative of e to the x, which is still e to the x, minus e to the x times the derivative of sine of x, which is cosine of x. Then the bottom of the fraction will equal low squared, so sine of x squared. Now remember, you can write the square of sine x as sine squared x. This is just a different way of writing the same thing. We can factor the numerator to clean it up a little, so that we have t prime of x equals e to the x times the quantity sine x minus cosine x, all divided by sine squared x. And that's our derivative. Let's try one last example. This one will require use of both the product rule and the quotient rule. Find the derivative of u of x equals x times sine x divided by the quantity 7 times x squared plus 2. Notice that this function is in fraction form, with a product in the numerator. Let's label the top f and the bottom g to make it easier to keep track of everything, where f equals x times sine x and g equals 7 times x squared plus 2. Now the quotient rule tells us that the derivative's numerator equals low d high minus high d low. So let's go ahead and figure out what f prime and g prime are equal to now. To get f prime, we need to use the product rule. First, we write x times the derivative of sine x, which is cosine x, and then we'll add sine x times the derivative of x, which is 1. Since g is a polynomial, g prime equals 14x. Now that we have f prime and g prime, we can use the quotient rule. Low d high means g times f prime. So we start by writing the quantity 7 times x squared plus 2 times the quantity x times cosine x plus sine x. Then subtract high d low, or f times g prime, which is x times sine x times 14x. Then the denominator of the derivative will be g squared, which is the quantity 7 times x squared plus 2 squared. The product rule and quotient rule are very useful tools, especially once they are committed to memory. And the easiest way to memorize them is to work through some examples on your own. Thanks for watching, and happy studying.